there are needs for data coming from different sources, need to integrate the data, cleanse them, curate them, transform them, and drive insights. And that insights need to be delivered to different user groups. They can subscribe or reports can be shared online to them, and there can be the decision intelligence or insight can be can be simple, and it can grow complex. Okay, and I'm assuming that the data can be in structured form, unstructured form, like you might be getting some email information, some PDF, scanned PDF, Word document. So I'm assuming that maybe there will be a situation where we need to deal with structured and unstructured data. Now, the first slide, when we start, it says that what if 40% of your data budget vanishes every year? This is the problem that we are trying to solve. Whether you are doing everything manually or using traditional approach, in fact, the data team, the data scientists, data engineers, everybody turns to be a plumber. The reason is, even to deliver a small report, they need to stitch 8 to 13 different tools before they can even do anything with their data. So the majority of the time, the entire team spent on creating those pipelines, plumbing work, and then there is a constant leakage from those pipelines, and team is constantly busy duct taping those pipelines. So the innovation, the business services, the data services, the insights, that kind of get off track. So because a majority of the cost and time that is spent, that what we call integration tax. So, and we, for the demo, what we did is we created a hypothetical scenario that receives data for different devices through IoTs, or they can be, this is just a presentation. The data source can be anything. It can be a API, it can be a file, it can be a database, it can be anything, or it can come from different sources. So hypothetically, data is coming from different sources. They need to be ingested, they need to be parsed, cleansed, transformed, and stored, and then we need to drive the analytics and metrics and results, alerts, right? So, and these analytics and metrics and reports, alerts need to be delivered to different user groups through different channels. Now, before I start, I'll ask few questions here, and if you have all the answer to these questions, probably in a minute, you can find those, or maybe in 30 minutes, then probably we don't need this session. If you got to answer what are the average network performance for each vendor as measured by the number of sites, average latency, and average signal strength. What about which access point has the most alerts? And how does network performance, retrade rate, latency, and client capacity differ between Cisco, Ruckus, and Juniper-based deployment? What are the common root cause for AP outage across all sites? Are there patterns related to switch port failures or port issues, power issues, and environmental factors? Identify all sites experiencing high interference or core channel conflicts. What channels are most problematic? Recommend an optimal channel plan. Now we are going to show you how we can answer four of these questions in less than 4 minutes. Okay. So I will log in here, and so assume that there is a database here. I come here and I will ask you those questions I have noted here. This is the one that's just I shown you. You come here, you show me the average network performance for each vendor, include the number of site, average latency, and signal strength. What it does, it automatically generates the SQL, and you just say run the query, and you get the result automatically here. Not only the result, you can get the data profile. I will get to the details of that. You can see the structure of the data. You can perform visualization, reports and stuff, charts and graphs without writing any line of code. And smart Viz, what it does, it takes your question and it identifies intelligently what are the charts and graphs that are important to represent pictorially these answers. So here, it has created all the charts, different bar charts and site count versus, VM vendor and average latency in milliseconds, things like that. So it automatically generated that. And so I said, identify the access points with most alerts. This helps operation teams focus on remediation effort on the worst offenders. So I come here and I run the query, and you get the results same way. You can see the charts and graphs and everything here. Now, these are the things that you develop once, and you can create a data product out of it so that you don't need to test and verify every time that you need have that questions. So different metrics and different calculations can be stored as a data product. So what we deliver is data as a product. So your reports, your data sets that you might be needing time to time, your predictions, everything is delivered as a data product. All these queries can be saved. You can come back here later on. Um, let's say, this is generate SQL that summarize network alerts by type severity. This provides a quick overview of the most common issues across the entire network. So this is the question that was answered before. All you need, you come here, you run the query, and you get the result. So your business team doesn't need to even worry about writing this. The reason why we show the program is for transparency, so that you know the data that you are seeing, how that is calculated. You can describe this SQL that is generated, so you know how step by step what is done and on what data is being used there. At the same time, what you see is the data profile summary. So which essentially tells you that what is what is the quality of your data? Are there alerts? What are the different column profiles? Without writing a code, you are seeing the result of the data through a lens that is called our data lens. And data lens, like a prism, it shows you different aspect of data, like the quality of the data, the tabular data, the schema, the visualization. Every aspect of the data you can just see without writing any code. Now, this is about the data that is coming from your structured data. But what if you have some data uh, that are unstructured, and so I create a chat here. I come here and I create a chat here, and then I'll start asking the question. I'm just showing you what, I'll show you how later. So let's say I ask this question here. I'm asking this question, what are the common root cause for AP outage across all sites? Are there patterns related to switch ports failure, power issues, and environmental factors? I want this a comprehensive report, and I ask this question here. So what it does is it look into search into a a repository of unstructured data, which can be PDF document, emails, it can be Word document, and it can be scanned PDFs, any unstructured data that you are coming, and it will search into the entire database, and then all the unstructured data, and then it will create a comprehensive report based on the question that you are asking here. So as you see here, within a second, it provided the common root cause, overview of the document site, different sites, and then the common root cause for AP outage, which is switch port failures, federal courthouse, health, first medical center, power issues, environmental factors, and then it says the patterns and the trends, and then it also provides the recommendations. Like what is your short-term immediate actions? It suggests that. So it's not only give you the answer of the fact, it also give you certain recommendations. So it says that identify all sites experiencing high interference or co-channel conflicts. What are channels are most problematic? Recommend an optimal channel plan to minimize interference. So it will analyze all your data, and then it will give you the facts. Then it will show you the critical areas, the problems, and then it gives you the recommendations. So what you see here is um, it it shows that sites experiencing high interference. So it find out those, and then the issues that are identified, radar detection events, all those things, problematic channels, Cascade Grand Hotel, Seattle. This is where the problems are, and then detailed analysis of the problematic channel, 5 GHz band analysis, and then 2.4, and then it shows the recommendations, general recommendations, specific channel assignments, and then it says step by step implementation step, what you need to do step by step manner. You conduct quarterly RF assessment, upgrade aging equipment, implement machine learning driven RRL. So it helps you to understand that. Now, there is no magic in this, the way we are representing. What we do is basically it uses a technology called RAG, Retrieval Augmented Generation, which will allow you to chat on your own data. You may ask I can ask question to ChatGPT or Claude, and that gives me answer. Yes, that give you answer based on what they know. They don't give you answer on your documents. And that document, that knowledge base, that can be used enterprise-wide. So in, in less than 5 minutes, what we have seen, we'll get to the details of it. What we have seen, very critical questions that we could answer in very quickly. Questions that we have answered, those are all natural language questions. User doesn't need to know SQL, Python, a lot of caffeines. They don't need that. All they need is ask the question what they need in natural language. And this is what is called the next generation conversational data management and analytics. We've been doing this research for many years. And what we build is not a little icing on the LLM layer. It's built on a very solid engineering foundation.